welcome everyone. I'm Chris Ballard, the CEO of Passive House Canada, and I'm really pleased to have you here today and answering some of your questions about a really interesting project. So I hope in the spirit of what we're all going through these days that you and your loved ones are safe and that we're staying positive and we will all get through this together. And now on with the show. Let me turn myself off and turn the slides on. I want to give you an overview of Passive House Basics, introduce myself and Rui Raposo, our guest today. I want to have a good conversation with Rui. We'll have some time for your questions and answers, and some information about Passive House Canada, education opportunities, and the like. So moving right along, and if you've been through past webinars with us, you know this slide, but I've done a lot of things in my life, from being a journalist, consumer advocacy work. I have been the Minister of Environment and Climate Change for Ontario and the Minister of Housing, the Minister responsible for Ontario's poverty reduction standards and project. I will say though that my experience has really convinced me that this is the way we need to build and retrofit if we're to meet our climate change goals, specifically our GHG reduction goals. What I personally brought me to Passive House was the standards are science-based, they're science-driven, they're verifiable, and there is no greenwashing. Passive House construction means healthy, resilient, and lower GHG emitting buildings, and that healthy and resilient, I think in today's world is especially poignant. And I will also say that Passive House Canada's education is the gold standard of high performance building instruction. So that's a little bit about me and the role that I'm playing here as CEO. I'm now into my 5th month as CEO, and it's very exciting times. I always like bringing this picture up because you may hear that Passive House is a German standard. It is it's nothing more than a marketing ploy to sell German windows and doors into the North American market. Nothing can be further from the truth. This is Saskatchewan Conservation House. It was built in 1977, funded by the federal government during the OPEC oil crisis of the day. For those of you of a certain age, we will say, you'll remember that OPEC oil crisis. The price of oil shot through the roof, and suddenly the cost to heat Canadian homes went through the roof as well. Federal government worked with a number of scientists, a fellow by the name of Dr. Orr, a building scientist, a physicist, if I recall, and a number of co-workers built this house. This house is acknowledged by the Passive House movement as the ancestor of the modern Passive House building standards. This house is still lived in today. It's still performing as it should to the standards that it was built to in 1977. So I think we Canadians can take some pride in saying that we are the ancestral home of the modern Passive House movement. So today I would like to introduce Rui Raposo. Rui is project manager with Humber College. He has a master's degree in architecture. He's currently focused on building awareness of embodied carbon calculations for new and for those buildings under renovation as well. So he's the perfect person to head up the Humber College project. One of his goals is to turn Humber College into one of the most energy efficient educational campuses in Canada. I can say that I know his research that Rui was involved with was around retrofitting houses to more energy efficient buildings with special attention on operational and embodied carbon. And last but not least, Rui has 12 years of practical hands-on experience with architecture in Canada, Portugal, and Brazil. So in a few minutes, we'll get Rui to turn his camera on and we'll begin our conversation. But before then, I want to answer a few questions, especially for those in the audience who don't know a lot about Passive House. You start with, what is a Passive House? It's really a building standard. And it is the most rigorous voluntary energy-based standard in the design and construction industry today. And you can see the picture on the slide shows that it's not just about single residences. A passive house consumes as much as 90% less heating and cooling energy than conventional buildings. It's also a methodology. It's a way of doing things. It's a way of building. It's a way of designing buildings to achieve that exceptional energy efficiency and superior thermal comfort. Heating and cooling loads are minimized through passive design. The result is a much healthier interior and resilient building. What is a passive house? It's not passive. It's just not for houses. Our name comes from the German passive house. It was the literal translation, may not be quite accurate, was the literal translation. But passive house, it's passive only in that the building envelope does most of the work to maintain comfortable temperatures. And this permits simpler, smaller mechanical systems. We're going to learn about that a bit more about the Humber College project today and how that played out. And it applies to both new and existing buildings. The EnerFit standard provides a proven and financially viable methodology for deep energy retrofits. And you know, for most of us living in metropolitan areas, it's going to be this area that we'll need to move on the deep energy retrofits. That's what we'll have to move on if we're to meet our GHG reduction targets. And I think that's why EnerFit is so darned important, because it's not just about energy. It's also making sure that you're building, you're renovating buildings to a safe standard, not just an energy, lower energy standard alone. So the advantages of a passive house, a very basic chart that we like to use, you know, it's super insulated building envelopes, higher quality windows with solar orientation, superior ventilation systems with heat recovery, thermal bridge free, airtight buildings. You feel better in one of these buildings, whether you're living, working, or playing, because it provides a year-round stable indoor air and air quality and temperature, quiet and comfortable throughout the changing seasons. There is a substantial reduction in energy use and operating costs, simple to use and durable systems in these buildings. And of course, there is a certain priceless peace of mind that goes with living, working in a passive house or EnerFit passive house building. So those are the key points, the key benefits of passive house building. Now we get on with the show, and I'd like to, this is a group that from Humber College, I toured their building early March when there was still snow on the ground, unlike today in Aurora, Ontario, where there is still snow on the ground, but we'll leave that moaning for another slide. Welcome, Rui Raposo from Humber College. Rui, if you want to turn your, if you would turn your camera on now, I will put the slides aside for a second. Well, no, actually, I think we're going.
I'm here right now.
Because there's some really cool slides you've brought along. Listen, thank you very much for joining us from your home office and my home office, and we'll have a series of an ability to answer some questions later on in today's webinar. But let's start. Sure. Let's start with one of the fundamentals. Can you tell us a little bit about Humber College? Not everyone is familiar with Humber, you know, where it is, and I'm specifically interested in its environmental goals. So fill us in on Humber College.
So Chris, first of all, I would like to say that I'm really glad to be here talking to you and all the participants in this webinar. It's really important for us to create this awareness over the industry. And Humber College was always focused on that. And in our department, we always try to get all our work spread out along all the Canada. And so it's really important for us to be here and explaining what were our experience going over a passive house building. So Humber College is a post-secondary institution that is located here in Toronto in the GTA area. Was established around 67, so 1967. And since that, we have been growing in terms of programs. And now we have around 33,000 full students. Wow. and 23,000 part-time students. So we have like a considerable impact in our community. And this we are spread around 3 different campuses. So, and in these three different campuses, we have around 3 million square feet of construction area. So it's pretty amazing. And most of these buildings have been here for a while, and they are now needing some renovations. And and this is why we have been doing all this work to get the existing buildings in a better performance, acting as a better energy performance buildings.
Mm-hmm. Good. So Humber College has an environmental and energy plan. Can you give us
in around 2014-15, Humber College worked and created an IMP, we call IMP, which is Integrated Energy Master Plan. And the goal for that is in the next 20 years around that. So by 2034, I would say, the goal is to reduce the energy consumption, the water consumption, and also the GHG consumption as well. So the idea was by 2034 to reduce in 50% of the water consumption in all the campuses, 50% on energy consumption, and 30% on the GHG emissions. So these are really aggressive targets for us, but it was the only way that we found to convince not ourselves but everyone around that this would be the best option to go forward.
Right.
So that's why we have been doing all these renovations, and I will probably talk about that in a few seconds.
Yeah. Sounds like a very aggressive plan, but a very important plan, obviously. So we get on to the matter at hand. Tell us about this project, and I will move some slides ahead.
Yeah. So we have the full team. You can see, everyone can see the full team.
Full team.
So we have like Spencer on the middle, that says our director, and it was the head of all this ideas since the beginning. We have also Aman on the left side, which is our project manager for the energy efficiency, and our professor on the center as well, that's has been working with us to create awareness all over the students. And so talking more about this building and what we have done to get to this point. So initially, and part of this targets that we established on our master plan, we have been renovating so far around 5 to 6 buildings already. We started with the one that we call Building N, that at that time was the first retrofit we did. But because we didn't achieve the targets we wanted at that time, we started looking for other options. So for this building N, I would say that we achieved 30% only reductions on energy and 43% reduction on the GHG emissions. So it was not close to what we wanted for our campus. So then is when we start looking to other options. And then along those options came this building Building NX, which used to be our entrance for the campuses. Right. So was the main building at that time in '89. It was when it was built. It used to be our central entrance to everything in the campus.
So
as you can see, as you can see in the picture, at that time maybe was considered like the state of art. But then along the time we started realizing that it was carrying huge problems. So initially it hosted the library for the campus, and then we did a renovate around, I'd say 5 to 6 years ago, to convert this into a biotechnology department. And so before it used to be a big open space inside, a huge volume that students would be there just for a couple of hours, I would say. And so they didn't feel the discomfort in their building. But now, after we moved all the biotechnology faculty to this building, and we start have permanent people using the space, being in the offices, we start getting complaints about draft. Also, as you can see, mostly or a huge part of the building was glass block, which we know that's not the best material in terms of thermal bridging and energy efficiency. And also we have this big front part, which is a curtain wall with a skylight at the top. So everything in terms of energy efficient, we'll find the worst cases in this building. And so after that, after started getting these complaints, and also again to meet our targets, we started looking for different options, for different standards, for different certifications that will achieve what we want in terms of consumption. So that's why then the Retrofit and Passive House came to the table. So we realized, that the Passive House and the Retrofit certification will be the right one for us to achieve a high efficiency in terms of energy consumption. So and so that's why we decided to go with the Passive House. So I can say, like, before, and unfortunately we don't have the exact numbers, but our estimation is before the consumption of this building was 300 kilowatts-hour per square meter. Before 300, which is kind of conservative from our hand, but was comparing with other existing buildings that we have along Toronto, is like an average for the existing building with 10-15 years old. And we were able with the Retrofit, with Passive House, to bring this down to 64 kilowatts square meter of consumption. So it's a huge reduction, talking about probably at least 70% of reduction in energy consumption.
And that's following with the Retrofit Passive House standards to get you there. That's very good. Well, I have on the screen the before and the after, and we can see the general outline is the same. There's still a lot of glass.
Yes. So this is the north part of the building, the north elevation of this building. And as you can see, so before you have all this glazing, that was creating too much glare inside, and we were able to reduce this wall ratio to 14% of glass compared with the whole elevation. So it's 14%. So it's a huge reduction, but you still can see that's a lot of glass around. And the people and the users still, like, initially they were concerned about having all this reduction in terms of glazing, because they were concerned about not having natural light coming in, but we noticed that now this is feel much more comfortable.
And I've got a picture, a slide I'll get to in a second that's taken inside. It was during our March tour. You can see the weather was very gray and overcast, but I'll show you in a second a picture when I was there, just taken with my my cell phone camera. But the first thing I wanted to talk about, the next picture I wanted to talk about is the envelope. Because we know, you know, the Passive House idea is about building the envelope. So can you tell us a little bit about the envelope and maybe some of the challenges that you faced in implementing an Retrofit standard for this building?
So for this Retrofits, we kept all the structure and we stripped out all the envelope because we needed to, and before even start looking for all mechanical systems, this standard tells us that we need to look for the envelope first. We need to look at how we can increase the thermal resistance of this envelope in order to use less mechanical systems at the end. And so for this option, and we decided to use two different components of insulation. So on the inside of the wall, we decided to go with the spray foam. And basically, because we need to create the air tightness level in this building that in the future will be able to pass over the test. So we decided not to create two layers of air tightness in this wall, just to be on the safe side. Doesn't need to be always like that, just to let you know. But for us, what's important, because we need to achieve this number at the end. And so, and on the outside, we went with mineral wool or rock salt, 8 inches of rock salt. That maybe, if you go back again, maybe we'll choose a different option for this, because the installation was kind of difficult. It took more time than we expected. because
Okay.
they are in two different directions. This is rock salt, and we need to create 2 layers of 4 inch each, and the installation took more time than we expected. But maybe in the future, and I think talking to some of the engineers, they're saying that much better solutions nowadays that we can use to speed up the process.
Okay.
But that time it was like one of the lessons learned was about the installation on the outside. And so for us was always the first idea, the first goal was to create this really robust envelope that will make us or create the R value that we needed. But not only that, there's other parts like the installation, but also the detailing around the envelope was really, really important. And we can see different materials performing really well when they are doing on labs, doing off the site. But when we bring everything to the site and we need to put all the puzzle together, is when we start seeing really challenges and struggling a bit more, because you need to create awareness on the trades first. Right. So you need to educate the trades how they should be installing this component. Right. And sometimes it's like the challenge part of this process.
And I'm going to insert an advertisement here for a couple of seconds, in that we've worked with Humber College to put on trades-related Passive House Canada training. For that very reason, we could have all the trained architects, engineers, building scientists that we need. But if we don't have people who know how to work in a passive house environment, whether it be a new building or an interfit building, then it just makes things a lot more difficult. So we have a lot of tradespeople who are very eager to take this type of training, and we'll look forward to working closely with Humber College in the future in Ontario, and we're offering the training across Canada, but certainly Humber College, to make these types of projects that much easier in the days ahead. There, the advertisement is over. Back to you.
That's a really important part. And also the importance of the communication, or the good communication between the designers, between the architects and engineers, and the trades. Everyone, it's very important. Everyone really focus on a goal since the beginning, and trying to understand that no one can do this work without the other one. It's impossible. It's impossible.
So when we go back, one of the challenges of building to passive house quality, or interfit to passive house quality, is before you do anything is to have that communications, right? And
exactly. That's the important part, because because so we have passive house that has a specific detailing that we need to follow regardless. They have like their specifications that need to follow. But then everything comes to the site. Everything comes to the site, and all we can put all together. So we were fortunate to have an amazing architects group, which was B plus Sage, and also the Morrison Hirschfield as the envelope engineers, that they really worked really hard to get everyone involved on this process. So and this was like really important for us.
Right. Very good, and very important to get that certification. So let me go on to the next slide here.
Yeah.
I was so impressed by the mechanical systems, or the lack of complex mechanical systems here. This was simply a dashboard showing us what was going on. I'm not asking for you to interpret it, but it was so for a layperson like me to understand what was happening in a building as big and seemingly as complex really spoke to how simple you can make the mechanicals in an interfit retrofit. But here's the picture I promised earlier about what the interior office space looks like. So on a very gray and overcast and dull day, we have a good amount of lighting coming in, natural lighting coming in. And I will tell you, like all passive house buildings I've been in, it was relatively quiet. And mechanically, from a mechanical perspective, it was quiet. There was no drafts or cold air dropping down on my head. No cold air leaking in from around windows. It really was a pleasant place to work. And I see there's one gentleman working away in a t-shirt, for heaven's sakes, in the middle of March on a snowy, cold day. So it's a very warm and wonderful place to work. And on a gray overcast March day. It was a pretty nice.
Yeah, it's amazing. So I always like to explain or to show this experience that we went through. So during a part of the construction, we need to turn the existing mechanical systems into a new mechanical system. And the picture we're showing on the left side is exactly the DOAs. It's our new air supply equipment. So during that time, and we schedule everything to happen in April, so 1 year ago, say.
Mm-hmm.
And the temperature outside was probably pretty much as we have today, or probably I think even colder than that. And for 1 week time, we need to turn off all the mechanical systems and turn on the new mechanical system. And we are kind of worried because for 1 week we will have anything running inside of this building, any mechanic, any heating, any cooling, nothing. And so we're concerned about this, about the staff, because they were using the spaces as normally. And what happened at the end is that during that week, we didn't get any complaint at all. So during the 1 week that outside was probably -5, -10 degrees Celsius, just the heating produced by the people and the equipment, the computer, was enough to maintain the temperature, the good temperature in the inside of the building. We'll talk about 21, 22 degrees. Just
Wow.
that.
Yeah.
No mechanical systems working at the time, nothing. Just the people and the equipment. So now you can see after that, we really noticed and understood there's the resilience of this new envelope of the building. So this was like one of the best experiences we had during the construction.
Yeah, that's a common comment we hear from folks, whether it be a single residence or a condominium or a building or community center. You know, people believe in the science of passive house. The numbers tell them it's going to work, but until you throw that switch for the first time, you are nervous. And it's a wonderful reaction when people say it actually worked. You know, our house, our building, our library was a very comfortable place to be, just using the heat from the people and the computers that are in this space. It's a wonderful thing to experience.
Yeah, and the passive house can provide us that. That's so.
Yeah, great. Okay, I have another picture that sort of goes beyond passive house, but it speaks to the solar panels you put on the roof of this building, and some of the other mechanicals that you have here as well. And I will say, I'll put a plug in again. When you're working to such a high performance standard, a passive house standard, to get to net zero or even 0+, even creating more energy than you use, is much easier, because you don't require much energy to heat or cool the building itself. So you don't need acres of solar panels. A few solar panels on the roof are all you need. So tell me about what's happening on the roof here.
So before in this roof, we have it completely packed with our air handling units. So we didn't have any space at all for nothing inside on top of this roof. Because we did all this process, we went to passive house, we turned pretty much all the roof into these small condensers that we can see over them in one of the corners, and we were able to get space for the panels, of the solar panels. So these solar panels give us around 25 kilowatt energy for the building. Mm-hmm. So it gives us probably around, I'll say, 10% of the energy required for the building. And the other good thing that I can tell about this one is, because most of the building is using electricity and then just be supplied by the solar panels, we needed, for some certifications, we needed to do a ratio and see how much, because our electricity is not totally clean. So there's a percentage that is not totally clean. And so to get a really net zero building, we needed to buy some racks. We saw the renewable certificates, and at the end it came at around $500
a year.
A year
to offset.
Just to offset the GHG emissions. $500 a year for a building with 48,000 square feet.
That's what I was just going to. that's a huge building.
Exactly. So it's pretty much nothing. And so just doing that, we have a building that is total zero carbon building.
Fantastic. Well, congratulations. And I will finish up by just another look at this very impressive building.
Thank you.
I guess as we count down, we talked about some of the challenges you faced around the building envelope. Were there other and making sure that you needed to have good communications from all the team members, from designers all the way through to tradespeople? There any other challenge that you would point us to? Any other lessons learned that we can pass on to the engineers, the architects who've tuned in today?
Yeah, so that's one thing. So after we finish this building, we have been tracking all the performance and also tracking as much as we can the efficiency in the building. And talking between the team, one thing that we noticed, and I already mentioned before, is that because we're having systems more and more efficient right now, we have amazing triple glazing windows that perform amazingly well. We have frames that they're perfectly working really well. We have all kinds of insulation. Now we need to start looking for some specific areas where you can maybe have some thermal bridging. And these specific areas, I would say that before was not impacting at all, because on overall building, the windows were having like a huge importance, the insulation were having like huge importance, but because they are getting better and better, now it will start looking for some details like in front of the slabs. Are we going to insulate in front of the slabs to make sure that we'll not have like a thermal bridging point over there? And so before they would account for 1% of the thermal bridging, but now it's getting like probably 50% of the thermal bridging. So at this point, we are now looking for specific areas that we will need to improve. We need to make more efficient to reduce even more the thermal bridging. And I'm saying just one of the options is in front of the slabs, but also foundations. So in this specific building, we need to dig down like 4 feet around the perimeter of the building to insulate the basement. So if we didn't have this idea, this strategy before, probably we're not having these amazing results.
Right.
Because since the beginning we said that initially, no, this is not that important, maybe. But nowadays, this is what's getting even more and more important. So this is like my advice, my lesson learned is that connections is that areas like for the slabs, like some part of connection roofs are really important, and the consultants and architects and engineers, they have a huge part to deal with this.
Right.
So this is like one of the things that I think it's important to raise all the time.
Very good. Well, listen, I'm going to turn off screen sharing right now, and I just wanted to again thank you very much for coming on board. And I look forward to, somewhere down the road, I'd like to get you back again and have some discussions about embodied carbon. Because I know at Passive House Canada, well, Passive House standards don't necessarily speak to embodied carbon, but Passive House Canada, our board of directors, many of our professionals, we are looking at how we can assist in that area, how we can start working that into the Canadian picture, this issue of embodied carbon. Passive House is all about operational carbon, of course, and as you've demonstrated with this Humber College project, you can take operational carbon from here down to here. The next step for all of us in this profession is to start addressing or to continue to address embodied carbon. So I look forward to in future having a conversation with you about that. But what I'll do now is I'll turn the floor back over to Stephanie, and who's been taking questions and I hope has a question or two for you.
Yes,
Stephanie.
so Rui, there's the first question is, what were the issues with the first project and why were the goals not reached?
Oh, so the building end. So mostly because the shape of the building was a kind of awkward shape. So we have a lot of slopes in some of the areas. When you deal with the box or something close to the box, you reduce the thermal bridging on the corners. And because that building has like a slope in one part of the elevations, it was really a challenge for us to address that. And also, initially, we thought that the roof will not have a huge impact, so we decided to maintain the roof on this first project. But then we realized that improving the roof, in terms of cost, is not that much, but in terms of energy efficiency, it goes like a big jump. So these are probably the two things. Yeah.
So that was the lesson learned that you brought into this project.
Exactly.
Okay.
So in this next building, we just went for a roof around R30, I'll say 25-30 to R50 effective roof. So we double the insulation on the roof for the energy.
I think I have about 4 or 5 other questions. So how is the indoor air quality ensured?
So we have, that's a screen that Chris mentioned is our DOA, so our dedicated outdoor air supply. And so this is working like 24/7 hour a week. And this is all monitoring by a software that provides for each space, provides the levels of CO2 in each area of the building. And what happened when you start seeing levels of CO2 going too higher in some spaces, this system automatically speaks to the doors, to the fan coils inside, and start moving air around. Initially, they will use the air that's inside of the building already, instead of going outside. So they use the air inside and to move to the spaces that are getting a CO2, a higher level of CO2. And if this is not sufficient, then we start pumping air from outside. So this is how it works. So because we have the software that can provide us information on a minute basis, maybe, we can always be tracking the level of CO2. So, and we have options to deal with that.
Okay, so the next question is, just want to confirm that you use both spray foam and mineral wool in the insulation, and did you consider using expanded cork for insulation?
So we used spray foam on inside and rock salt mineral on the outside. We looked for the cork, but we didn't have a good supply that will help us to achieve what we needed. And the whole strategy was always to get these 2 layers, as I said, 2 layers of air tightness in the building. So the rock salt, because in terms of sustainability, is better than is much better than the spray foam and the fiber. So we decided to maintain on the outside, but on the inside, to guarantee that we'll have this air tightness that we needed, the only option we had was the spray foam.
That's the spray
which
foam.
We know that in terms of sustainability is probably more harmful. It's more harmful than the other ones, but on the other hand, give us the air tightness that we needed.
Yeah, great.
Just a trade-off.
Did you access any funding opportunities to assist with any of these projects, and if so, which one?
That was a good question. Yeah, so we're fortunate.
I didn't plan, by the way.
You can even talk about that as well. So we are fortunate to take part of the cap and trade, the government plan that was in place at that time. I think it was at 2017 or 16, something like that. And we were able to get the funds for the total project from there. And even when they got extended, we already had the funds for that. So we are fortunate to get this the project totally funded by the government.
Yeah, through the government's cap and trade program. Yeah, the Ontario government's cap and trade program. Yeah, exactly. It funded a number of projects on campuses and college and university campuses across Ontario, and I'm so delighted to see this as one of the outcomes.
Exactly. We are looking to get more in the future.
Next question: estimated payback period for the cost.
So it's kind of difficult for us because this building initially was connected with all the rest. So we didn't have separate meters for this specific building. So we didn't have a good idea what was this building consumption before. And then now in the future, we have been trying to get these calculations, but was never our goal. Our goal was more to create awareness, to create an example that everyone will be able to see it. So we're still like looking what will be the benefits of a long term, but we don't have like exactly what is the number for that. But we know that we're heavy savings. So after 1 year, we can see the consumption that got like much lower right now. But we didn't spend so much time doing this exercise because was never our goal. Goal was to create a better environment for the users, was to create awareness and explain that this is possible. This is possible to be done. And even in terms of costs, it's always difficult for us to measure that as well, because we didn't have time to talk about that. But there was a lot of struggles along the construction, mostly because our user was using the space at the same time we were building. And so this kind of constraints that we don't have in other buildings that we had on this one. So
people were still people were still working in the building as you were trying to do construction around it.
Exactly.
So a number of these things lead to an increased cost, not necessarily because of your building to a passive house standard, but how you had to do the work.
Exactly.
So I mean, we'll be able to make some estimates in future. We know if you take the average cost for a building like this in the Toronto area, and you spoke about that at the beginning, and we now know what energy use is as well. So you probably could do some thumb back of a napkin calculation. Let me, sorry, 1 second. The big thing is, how do you put a cost on? It's hard to put a cost on a better working environment, which is really what this delivers in spades. And the other thing it does is it's taught you some very valuable lessons, which you can teach the rest of us. And that was one of the one of the outcomes from this project was lessons learned.
Yeah, and also, so that we got the funds to build this to retrofit this building. Was not like an enormous amount in terms of fund, but was enough to make it happen.
Yeah.
So we costed everything using the fund, and I would say maybe it will cost probably. It's difficult to commit with a number, but 5% premium, 10% premium, but with all these constraints around. And so it's really difficult. What I can say is that we can do it. We can do it without like having extreme efforts and cost being extremely higher than other buildings.
And these are these. Okay, go ahead, Stephanie.
Sorry, there's a lot of questions.
Yeah.
If everyone has a couple minutes, I'll just keep asking until we can get through the list.
We need to make another session.
Yeah. Was the material of the sill drainage? What was the material of the sill drainage flashing? Was it aluminum, large thermal bridge?
Aluminum. It was aluminum flashing. Yeah. Okay. Aluminum flashing. Yeah, at the bottom of the windows, and all around we had, and you can see this detail on a passive house standard. We had insulation overlapping the frames on the exterior side. That was aluminum, yeah.
Okay, so the next question is, does disposal enter into the passive house equation?
Not really, not that much. Is one of the things maybe in the future should be included. But
the question was whether there was a significant amount of glass block.
In terms of disposal?
Mm-hmm.
No, so in passive house, it really doesn't measure the disposal of that. And I think the whole idea of this energy is mostly to renovate a building that is existing. So even though there's a disposal, we need probably to turn down all the envelope and build a new one, but you're always taking part of the existing structure. You're always taking part of everything that create this building, and then you're gonna be maintaining in the future. And this then turns into the other subject that Chris already mentioned, the embodied carbon, which has a huge impact. But we didn't get exactly the measure about that. Yeah.
Great. I'll give one last question, and it said, based on the estimate annual savings, can it be compared to the cost? I.e., is it a 20-year payback or a 100-year payback?
This again, going back to that number, it's difficult. It's difficult for us to get the number because of all of the constraints around this. But I would say around probably 30 years maximum. But it's difficult. So in our case, because the building is connected with other buildings, so it's not like a standalone building that doesn't have anything around. So this building is connected with other ones, and so some of the energy that probably we are feeding other buildings, maybe with the energy that we are supplying inside of the annex. So it's kind of difficult for us in this case to get these numbers for sure.
Yeah. And it sounds to me, because we've had a few questions about this, so it sounds to me that we'll make note of this area of interest and find some projects that weren't complex to measure at the beginning, but we could spend a whole session talking about payback.
Yeah.
Okay, great. That's I think that's all we have time for.
Okay, well, that's wonderful. Thank you very much, Rui. I appreciate your time, and I appreciate you sticking with the Interfit and going through the process. Everyone says the same thing. The first time it can be difficult. You had a great team working with you, and you understood the need for communication. You've highlighted the need for good training for everybody involved. And so we look forward to your next project. Look forward to having you back on the show to talk about embodied carbon, because that's where we really need to move next as in this industry as builders. So thank you very much. I will invite you, both of us, to turn our cameras off now, and I'll wrap things up with a few more slides, and then we're.
Thanks so much. Thanks so much for having me. Thank you so much.
Very good. Thank you very much. So let me move along, and where I wanted to go next was just tell you a little bit about Passive House Canada, and I do this every week, but I think it's important. Our mission at Passive House Canada, our mission is to make the international Passive House standard of building performance understood, achievable, and adopted by government, industry, professionals, building suppliers, and consumers all across the country. And we're doing this through education, advocacy events, and building projects and webinars like this. We're a not-for-profit professional organization. We've been working in high-performance building standards. We're founded in 2013. And as I said, we advocate for the adoption of the Passive House standard through government relations and extensive education programs and national events. So we are the Canadian affiliate of the International Passive House Association. We're also a member of the North American Passive House Network. It's important, if you believe in high performance buildings, in passive house construction, passive house Interfit renovation, that you become a member. And there's a handout attached to this presentation where you can learn more of the benefits of becoming a member. One of the best benefits, I'll tell you though, by far, is becoming part of a very passionate passive house family, where you will find folks who are competing against one another in the marketplace, but you know, over a glass of wine or a beer at one of our social events or in one of our discussion rooms, they're working together to solve broader issues around building construction. So it's a really nice and supportive place for you to belong. And if you are a member, then you also get some significant discounts on our education, because we heard, as we heard Rui point out, it's really all about education. You know, making sure that we have tradespeople who are educated, engineers, architects, building scientists, and consumers, because we need consumers to say, this is the quality of building that we need. I will point out that in November is our Passive House Canada conference called, this year's theme is Building for Resilience. I think it's a perfect theme given what we're going through these days with the climate crisis and COVID-19. So you can find more information attached. And finally, I will make a final pitch for our upcoming courses, Pathway to Certification, members receive an additional 20% off our 120 series online. This prepares you, primarily professionals, for passive house certification. It's a great way to, as HR folks would say, future-proof your career. But as virtually all Canadian jurisdictions move towards high-performance building standards, the building codes are being changed to reflect that. There is no better way to move down that path than through our Pathway to Certification program. And if you visit our website, there's other programs, introductions. If you want to learn more about Passive House, we have all sorts of great information on our website. So I'm going to leave it there for today, and I will thank Rui from Humber College for joining us and sharing just some of the lessons learned from his participation in this Humber College project. And thank you to Humber College for making the decision to move to a Passive House Interfit standard. And we look forward to the day when they get their Interfit certification from Passive House International bolted to the wall. It will be richly deserved. And I think this building and people like Rui provide a great example of what we can do in areas like Toronto and all across Canada. So thank you very much, everyone, for being online today. Join us next week where we have a really entertaining session lined up. We have a builder, a fellow by the name of Mark Bernhardt, who will present the things I've learned, the lessons I've learned, and the mistakes I've made as a builder. Quite entertaining fellow. And once again, there's lots to learn from folks who've gone ahead of us. So I look forward to having you online next Wednesday at noon. In the meantime, everybody stay safe. Let's stay positive. We'll get through this together. Take care.